May 1st, 1945, 160 feet beneath the North Atlantic, 52 degrees 14 minutes north, 10 degrees 32 minutes west. Captain Lieutenant Elektroboot Schnee stood in the control room of U-2511, his hands gripping the periscope housing as the most advanced submarine ever built glided through the depths at a speed that should have been impossible. 24 knots submerged, silent, invisible, deadly. Around him, his crew moved through their duties with efficiency born of intensive training, but their faces betrayed something Schnee had never seen in 7 years of U-boat command: fear of their own vessel. The Type XXI U-boat was Germany's answer to impending defeat, a submarine so revolutionary it made every previous undersea vessel obsolete. It could outrun destroyers while submerged. It could dive to depths that made depth charges ineffective. Its battery capacity allowed it to remain underwater for days without surfacing. Its weapon systems could fire a full spread of torpedoes and reload in 12 minutes, a feat that took conventional U-boats an hour. But there was a problem. The submarine was almost too advanced for the men operating it. The hydraulic systems operated at pressures that could crush a man's hand if improperly handled. The electrical systems drew power at levels that could arc weld flesh to metal. The diving depth exceeded safe operational limits of every component not specifically redesigned for the vessel. And the speed, the terrifying speed that pushed the hull's structural limits, created stresses no German submarine had ever endured. Schnee had just completed the perfect attack. His periscope had tracked a British cruiser, HMS Norfolk, for 30 minutes. He had maneuvered into firing position without being detected. His torpedo room had loaded 6 T5 acoustic torpedoes, each capable of homing on the cruiser's propeller noise. The firing solution was perfect. Range, 500 meters. Speed, 28 knots. Bearing, constant. The cruiser was dead if Schnee chose to fire. He didn't. Instead, he gave the order his crew had been trained to expect but hoped never to hear. Secure from attack stations. Take us deep. Course 270. Silent running. The date was May 1st, 1945. Adolf Hitler had been dead for 24 hours. Berlin was falling to Soviet forces. The Third Reich had approximately 1 week to live. Captain Lieutenant Elektroboot Schnee was conducting the last war patrol of the Kriegsmarine's most advanced submarine, knowing that firing those torpedoes would accomplish nothing except prolonging a war already lost and condemning his crew to death when the inevitable counterattack came. The irony was profound. Germany had finally built the weapon that could have won the Battle of the Atlantic, but it arrived 3 years too late. The Type XXI represented technological capabilities that Allied naval forces couldn't match and wouldn't match for years. Yet it entered service when Germany had already lost control of the seas, lost access to vital resources, and lost any possibility of strategic victory. This is the story of how Nazi Germany's most advanced submarine became operational just as the war ended. It's the story of engineering brilliance applied too late to matter. And it's the story of crews who sailed vessels so advanced they bordered on experimental, knowing their technological superiority couldn't change Germany's inevitable defeat. The Type XXI's development began in desperation. By mid-1943, the Battle of the Atlantic was decisively turning against Germany. Allied aircraft equipped with centimeter radar and improved depth charges were destroying U-boats faster than German shipyards could build replacements. The convoy system, combined with escort carriers and long-range patrol aircraft, had made surface operations suicidal for submarines. The traditional U-boat tactics, surface at night to recharge batteries, attack on the surface using superior speed, were no longer viable. Gross Admiral Karl Donatz, commander of the U-boat force, demanded a submarine that could operate entirely submerged. Not for hours, but for days. Not at crawling speeds, but at velocities that could overtake convoy escorts. The specifications seemed impossible. 16 to 18 knot submerged speed, 48-hour underwater endurance, rapid reload torpedo systems, and diving depth of 250 meters. The design team, led by Professor Helmuth Walter and engineer Captain Hans-Joachim Schwartz, created something unprecedented. The Type 21 displaced 1,621 tons surfaced, 1,819 tons submerged, 50% larger than previous fleet submarines. But the size was necessary to accommodate revolutionary systems. The hull design was completely reimagined. Previous U-boats used a traditional submarine shape optimized for surface performance with adequate submerged capability. The Type 21 inverted this philosophy. The hull was designed for submerged hydrodynamic efficiency, with every external fitting streamlined or eliminated. The conning tower was reduced to a minimal sail, housing only essential periscopes and snorkels. The outer hull was smoothed until it approached the ideal teardrop shape that would become standard for all subsequent submarines. The battery capacity was tripled compared to Type 7 U-boats. 3 battery rooms contain 372 lead-acid cells, arranged in 2 main batteries and 1 auxiliary battery. The combined capacity was 186,000 ampere-hours at 110 volts, enough power to drive the submarine at 16 knots submerged for 90 minutes, or at 6 knots for 48 hours. This represented more stored electrical energy than some small towns consumed daily. The electric motors were completely redesigned. 2 main propulsion motors provided 4,000 horsepower combined, twice the power of previous U-boats while being more compact. The motors used advanced cooling systems and bearing designs that reduced friction losses. More significantly, they incorporated creeping motors, small auxiliary motors producing just 226 horsepower that could drive the submarine at 5 knots almost silently, making acoustic detection nearly impossible. The torpedo systems were revolutionary. Previous U-boats carried 14 torpedoes, 4 in bow tubes, 1 in stern tube, and 9 reloads. Reloading required manually hauling 3,500-pound torpedoes through cramped spaces using chainfalls, a process taking 45 to 60 minutes per tube. The Type 21 carried 23 torpedoes, 6 in bow tubes with 17 reloads stored in a mechanized loading system. Hydraulic hoists moved torpedoes from storage to tubes in 12 minutes for a full 6-torpedo reload. The submarine could fire 18 torpedoes in less than 30 minutes, devastating firepower that would saturate any convoy defense. The fire control system was equally advanced. The Type 21 incorporated an analog computer that calculated firing solutions based on target range, speed, bearing, and angle on the bow. The system integrated sonar data, periscope observations, and radar information automatically. The commander could track multiple targets simultaneously and fire torpedoes without surfacing or even raising the periscope to attack depth. This represented fire control sophistication exceeding contemporary surface ships. The sonar systems were the most advanced Germany had produced. The main passive array, the Balkengerät, consisted of 48 hydrophones arranged in a circular array in the bow. This system could detect convoy propeller noise at ranges exceeding 50 kilometers in good conditions. The directional accuracy was sufficient for torpedo attacks without visual observation. An active sonar system provided ranging data, though its use was restricted because active transmissions revealed the submarine's position. The snorkel system allowed diesel engine operation while submerged. The Type 21 could cruise at periscope depth, drawing air through the raised snorkel while running diesels to charge batteries. This eliminated the need to surface, removing the submarine's greatest vulnerability. The snorkel incorporated automatic valves that closed when waves washed over the intake, preventing flooding. The system worked, but it created problems crews hadn't anticipated. When the snorkel valves closed, the diesel engines, consuming massive amounts of oxygen, would create partial vacuum inside the submarine. Crew members experienced painful pressure changes in their ears and sinuses. In extreme cases, the pressure differential could cause eardrum rupture. Men learned to recognize the sound of snorkel valves closing and would equalize pressure by holding their noses and blowing, but the constant pressure changes caused chronic sinus problems and hearing damage. The diving depth capability was theoretical rather than proven. The hull was designed for 250-meter depth, nearly double the 135-meter depth rating of Type 7 U-boats. The increased depth capability came from hull construction using welded steel plates of improved metallurgical quality. But the welding technology was pushed beyond established limits. Welds had to be perfect. Any flaw would become a failure point at depth. The quality control required exceeded what German wartime production could consistently achieve. The first Type 21 was laid down on April 19, 1944, at Blohm & Voss shipyard in Hamburg, Germany. The construction method was revolutionary. Instead of building the submarine traditionally from keel up in a single shipyard, the Type 21 was built in 8 prefabricated sections at different locations, then transported to assembly yards for final construction. This modular construction was inspired by American mass production techniques and represented complete departure from traditional German shipbuilding practices. The construction program was overseen by Albert Speer's Ministry of Armaments and War Production, with Otto Merker directly managing submarine production. The plan called for building 40 Type 21s per month starting in late 1944. This production rate would have provided 480 submarines by mid-1945 if the optimistic projections were accurate. The reality was catastrophic. The prefabrication program required precision manufacturing across multiple facilities that had never coordinated production before. The sections had to fit together with tolerances measured in millimeters. Welding had to meet exacting standards. Electrical systems required precise installation. Hydraulic components needed perfect alignment. Every aspect demanded quality control that German industry, decimated by Allied bombing and resource shortages, struggled to provide. The first Type 21, U-2501, was launched on May 12, 1944. The submarine immediately experienced problems. The hull sections didn't align properly, requiring extensive rework. Electrical systems shorted out during initial testing. Hydraulic lines leaked under pressure. The diesel engines vibrated excessively, causing equipment failures. The battery rooms flooded during dive tests. The torpedo loading system jammed repeatedly. Nearly every system required modification. The problems weren't design flaws. They were manufacturing defects caused by the rushed construction schedule and quality control failures. But fixing them required returning the submarine to shipyards already overwhelmed with work. U-2501 spent 4 months in repairs before being declared operational. The second Type 21 experienced similar problems. So did the third. The pattern continued through the entire construction program. By January 1945, 118 Type 21s had been launched. Of these, exactly 2 were certified combat ready, U-2511 and U-3008. The others remained in various stages of repair, modification, or extended sea trials. The submarines existed, but they weren't functional weapons. They were complex machines built too quickly with insufficient quality control, operated by crews who were still learning how to use systems unlike anything they'd experienced. The crew training program illustrated the Type 21's complexity. Traditional U-boat training took approximately 4 months. Basic submarine school, specialized technical training, and tactical exercises. Type 21 training required 8 months. Crews had to master hydraulic systems, advanced electrical systems, complex fire control computers, sonar operations, and the peculiar characteristics of a submarine that handled unlike any previous vessel. The handling characteristics were particularly challenging. Traditional U-boats accelerated slowly, turned gradually, and dived at controlled rates. The Type 21 accelerated like a surface ship, turned so sharply that inertia threw crew members against bulkheads, and could dive at angles approaching 15 degrees, steep enough that unsecured items would slide across decks. The submarine's size meant it had significant momentum. Stopping required careful planning because the mass would carry forward even after engines were reversed. The electrical systems demanded constant attention. The massive battery banks generated hydrogen gas during charging, an explosive hazard requiring careful ventilation procedures. The high-current switchboards could arc catastrophically if improperly operated. The motor controllers, using advanced thyristor technology, were temperamental and prone to failure if overloaded. Electricians' mates trained specifically for Type 21 operations still struggled with systems that pushed the boundaries of contemporary electrical engineering. The torpedo loading system, while theoretically revolutionary, was mechanically complex and prone to jamming. The hydraulic hoists required precise alignment. The torpedo guides needed perfect maintenance. Any contamination in the hydraulic fluid could cause valve failures. The system worked beautifully when properly maintained by experienced crews in ideal conditions, conditions that rarely existed in combat. Captain Lieutenant Adalbert Schnee, selected to command U-2511 in March 1945, was among Germany's most experienced submarine commanders. He had commanded U-21 on 9 patrols in the Atlantic and Mediterranean, sinking 20 ships, totaling 89,047 tons. He understood submarine warfare at a visceral level. When he first toured U-2511, his reaction was recorded in his patrol log. This vessel represents capabilities I could not have imagined possible 3 years ago. It also represents complexity that concerns me. We are taking experimental technology into combat with minimal testing. The potential is extraordinary. The risks are equally significant. His crew shared these concerns. Oberleutnant zur See Hans Werner Kruse, the executive officer, had served on 3 previous U-boats. His assessment, written to his family before the patrol, captured the crew's ambivalence. We sail in a submarine that can do things no previous boat could achieve. We can outrun destroyers underwater. We can attack without surfacing. We can dive deeper than their depth charges can reach. But the boat frightens us. It's too new, too complex, too untested. We're learning the systems while using them operationally. Every day reveals new quirks, new limitations, new dangers. The engineering crew faced particular challenges. Obermaschinist Mott Karl Hoffmann, chief engineer, was responsible for systems that operated at power levels and pressures his training hadn't covered. The diesel engines produced 4,000 horsepower each, twice the power of previous U-boat diesels. The exhaust systems handled temperatures that could ignite fuel vapor if leaks occurred. The hydraulic systems operated at 3,000 psi, pressure sufficient to inject hydraulic fluid through human skin if lines ruptured. The electrical systems could deliver currents that would kill instantly if safety procedures weren't followed perfectly. The battery rooms required constant monitoring. During charging, the batteries released hydrogen gas at rates that could create explosive mixtures in minutes if ventilation failed. The cells operated at temperatures approaching 50 degrees Celsius, hot enough to cause severe burns. The electrolyte solution was concentrated sulfuric acid that would dissolve flesh. Men working in the battery rooms wore protective gear and followed procedures that left no margin for error. The first war patrol of U-2511 began on April 30, 1945, from Bergen, Norway. Schney's orders were deliberately vague. Patrol the waters west of the British Isles. Interdict shipping if opportunities presented. Evade detection and await further orders. The ambiguity reflected German Naval Command's recognition that the war was ending, but unwillingness to formally acknowledge defeat. The transit from Bergen to the patrol area demonstrated the Type 21's capabilities and limitations. The submarine cruised submerged at 10 knots continuously for 36 hours, a feat impossible for conventional U-boats. The crew marveled at the endurance and speed, but they also discovered operational realities that training hadn't fully prepared them for. The submarine's size made it respond slowly to control inputs. Diving officers accustomed to smaller boats initially over-controlled, causing oscillations in depth. The learning curve was steep. Mistakes at high speed could cause depth excursions that stressed the hull dangerously. Lieutenant Zorze Wolfgang Meyer, the diving officer, wrote in his log, "Controlling this vessel requires completely relearning depth control. She has tremendous inertia. Small corrections made early are preferable to large corrections made late. But judging what corrections to make requires experience we don't yet have." The noise levels surprised everyone. Despite the advanced sound isolation, the submarine generated significant noise from water flow over the hull at high speed. The rushing sound was audible throughout the vessel, a constant reminder of their velocity. The crew initially found this disturbing. Previous submarines were relatively quiet when submerged. The noise wasn't loud enough to compromise acoustic stealth, but it was psychologically unsettling. The vibration at high speed was equally concerning. The hull would develop harmonic vibrations at certain speeds, causing everything to shake rhythmically. Equipment that wasn't properly secured would work loose. The vibrations caused chronic fatigue among the crew, who described feeling like they were inside a giant tuning fork. Reducing speed eliminated the vibrations, but that defeated the purpose of the submarine's high-speed capability. The snorkel operations revealed problems that would plague all subsequent snorkel-equipped submarines. Running on the surface was faster and more efficient, but it exposed the submarine to radar detection. Running submerged on batteries was safe but limited endurance. The snorkel was supposed to offer the best of both options, underwater stealth while recharging batteries. But the reality was uncomfortable. The diesel engines consumed enormous amounts of air. When the snorkel valves closed due to wave action, the engines would create partial vacuum inside the submarine. The pressure drop was dramatic. Ears would pop painfully. Men with sinus problems experienced severe pain. The automatic air induction valves would open, allowing compressed air from storage tanks to equalize pressure, but this consumed precious compressed air that was needed for other purposes. The crew learned to time activities around snorkel operations. If you needed to use the head, toilet, you did it before snorkeling began, because the pressure fluctuations made the plumbing misbehave unpredictably. If you were eating, you finished your meal first, because the pressure changes caused nausea. If you were trying to sleep, you gave up, because the pressure fluctuations made rest impossible. The patrol lasted 8 days. During that time, U-2511 detected numerous targets, convoy escorts, individual merchant ships, patrol craft, and on May 1st, the cruiser HMS Norfolk. Each detection was accomplished using the passive sonar array, which performed even better than specifications suggested. Schnee could track contacts at ranges exceeding 40 kilometers, classify them by propeller noise characteristics, and develop firing solutions without ever using the periscope. The Norfolk encounter demonstrated both the submarine's capabilities and the futility of using them. Schnee detected the cruiser at 0437 hours on May 1st at range of 62 kilometers. He maneuvered U-2511 into attack position submerged, using only sonar data. The approach took 3 hours, during which the submarine maintained 12 knots submerged, a speed that would have exhausted conventional U-boat batteries in 20 minutes. The Type 21's batteries barely decreased in charge state. At 0734 hours, Schnee raised the attack periscope for visual confirmation. HMS Norfolk, a County-class heavy cruiser displacing 9,925 tons, steamed at 28 knots on course 095. The firing solution was perfect. Range 500 meters. Target speed 28 knots. Bearing rate minimal. The cruiser was completely unaware of U-2511's presence. Schnee had 6 T5 Zaunkönig Ren acoustic torpedoes loaded and ready. These torpedoes were designed specifically for attacking escorts. They would home on propeller noise, making evasion nearly impossible. Against a cruiser traveling at high speed, creating massive propeller noise, they would be devastatingly effective. Schnee could have fired all 6 torpedoes in a spread that would have guaranteed multiple hits. The cruiser would have been crippled or sunk. Instead, Schnee ordered the periscope lowered and took U-2511 deep. His decision was based on information received via radio the previous evening. Hitler was dead, Berlin was falling, and Admiral Dönitz had assumed leadership of what remained of Germany. Schnee understood that continuing offensive operations would accomplish nothing except killing Allied sailors and guaranteeing his crew's death when the inevitable counterattack destroyed U-2511. The crew's reaction to this decision revealed their state of mind. Relief was the predominant emotion. These men knew the war was lost. Continuing attacks meant dying for a cause already defeated. The Type 21's capabilities, which should have filled them with confidence, instead highlighted the tragedy of their situation. They possessed a weapon that could have changed the war if it had arrived 2 years earlier. Now it was simply a very sophisticated way to commit suicide. The psychological burden of sailing the Type 21 extended beyond operational concerns. The crew understood they were experiencing technology that represented the future of submarine warfare. But that future belonged to their enemies. Germany would lose the war. The Type 21 and its capabilities would be captured, studied, and copied. The men sailing U-2511 knew they were training their future adversaries in how to use weapons that would be turned against Germany's successors. This knowledge created cognitive dissonance that affected crew morale. They took pride in their vessel's capabilities while simultaneously understanding that demonstrating those capabilities provided intelligence to enemies who would exploit it. Every test of systems, every maneuver demonstrating performance, every combat simulation was potentially teaching Allied intelligence analysts something valuable about the submarine's capabilities. On May 4, 1945, U-2511 received orders to cease offensive operations and prepare to surrender. Admiral Dönitz had ordered all U-boats to surface, broadcast their positions, and proceed to designated Allied ports for surrender. For the crew of U-2511, this meant the most advanced submarine in the world would become a war prize without firing a shot in anger. Schnee's final patrol log entry captured the futility. We have demonstrated that the Type 21 possesses capabilities that would have been decisive 2 years ago. We can attack submerged with accuracy previously impossible. We can evade escorts with ease. We can remain on station indefinitely. But these capabilities are meaningless now. The war is over. Our technological achievement arrives too late to matter. The submarine surfaced on May 5, 1945, displaying the required black surrender flag. Schnee transmitted U-2511's position and course to Allied authorities. The crew secured weapons, prepared the vessel for boarding, and waited for instructions. The emotional state ranged from relief at surviving the war to despair over surrendering such an advanced vessel to enemies who would reverse engineer everything. HMS Red Mill, a River-class frigate, intercepted U-2511 on May 6, 1945. The British boarding party was astounded by what they found. The submarine's size, systems, and capabilities exceeded anything British intelligence had predicted. The boarding officer's report noted, "This vessel represents quantum leap in submarine technology. If Germany had deployed these in quantity 2 years ago, the outcome of the Battle of the Atlantic would have been very different." U-2511 was sailed to Lissahalli, Northern Ireland, arriving on May 14, 1945. British and American technical intelligence teams descended on the submarine, documenting every system in exhaustive detail. The examination reports filled thousands of pages. Every innovation, the streamlined hull, the massive batteries, the hydraulic torpedo loading, the advanced sonar, and the fire control computer were photographed, measured, and analyzed. The crew was separated and interrogated extensively. Naval intelligence wanted to understand not just the technology, but the operational doctrine. How was the submarine employed tactically? What were its limitations? How was the crew trained? What problems had they experienced? The interrogations revealed that while the technology was revolutionary, the implementation had been rushed and problematic. Kapitänleutnant Schnee was interrogated by Commander Kenneth Knowles, the U.S. Navy's top U-boat intelligence analyst. Knowles' report provided insights into the Type XXI's combat potential and limitations. Schnee confirmed that U-2511 possessed capabilities exceeding any submarine currently in Allied service. The submerged speed and endurance would have made convoy defense extremely difficult. However, he also confirmed that the vessel's complexity created operational challenges. The rushed production schedule caused quality problems throughout. Many systems worked, but not reliably. He estimates that with proper development time and quality control, the Type 21 would have been devastating, but Germany lacked the time and resources for proper development. The technical analysis supported this assessment. The Type 21's design was brilliant, but the execution was flawed. Hull welds showed inconsistent quality. Electrical systems had reliability problems. Hydraulic components were poorly manufactured. The diesel engines suffered from inadequate lubrication systems. The battery cells were of varying quality due to manufacturing shortcuts. The torpedo loading system worked but required constant maintenance. Every innovation showed evidence of being implemented too quickly. The implications were significant. If Germany had begun Type 21 development in 1941 instead of 1943, allowing proper testing and quality control, the submarines could have entered service in 1943 in reliable form. A force of 100 to 200 Type 21s operating in the Atlantic in 1943 to 44 would have devastated convoy operations. The Allies had no effective countermeasure to submarines that could attack from submerged positions at extended ranges and evade escorts through superior speed and endurance. But Germany didn't begin development until the Battle of the Atlantic was already turning against them. The decision to pursue revolutionary design instead of evolutionary improvements cost 2 years. By the time the Type 21 entered service, Germany lacked the shipyard capacity, material resources, skilled workforce, and most critically, time to produce them in meaningful numbers with adequate quality. The production statistics told the story. Between 1944 and 1945, German shipyards laid down 118 Type 21 U-boats. Of these, 119 were launched. One was completed using components from a damaged vessel. 4 were destroyed by Allied bombing before completion. Only 2 became fully operational, U-2511 and U-3008. The others remained in various stages of repair, modification, or extended trials when the war ended. The cost per submarine was equally revealing. Each Type 21 cost approximately 6.2 million Reichsmarks, double the cost of a Type VII U-boat. The prefabrication program required massive infrastructure investment, new assembly facilities, specialized tooling, training programs for workers unfamiliar with submarine construction, and quality control systems that never functioned adequately. The total program cost exceeded 800 million Reichsmarks, resources that could have built 300 conventional U-boats or significant numbers of tanks, aircraft, or other weapons. The strategic implications were debated extensively after the war. Some historians argued that the Type 21 program was misdirected effort, resources wasted on sophisticated weapons that arrived too late while Germany desperately needed conventional weapons immediately. Others contended that the program demonstrated Germany's capacity for innovation, even under extreme pressure, and that the timing failures reflected broader strategic mistakes rather than the submarine design itself. Admiral Karl Donitz, testifying at his war crimes trial in 1946, defended the Type 21 program. The Type 21 represented our best hope for regaining control of the Atlantic. If we had succeeded in deploying them in significant numbers earlier, the outcome of the war at sea would have been different. The design was sound. The operational concept was valid. We simply ran out of time. Allied naval officers who examined the captured Type 21s reached similar conclusions. The technology was genuine, and the capabilities were real. Britain's Royal Navy immediately began planning submarines incorporating Type 21 features. The U.S. Navy initiated the Guppy program to modify existing submarines using lessons learned from the Type 21. The Soviet Union, which captured several incomplete Type 21s in German shipyards, used them as the basis for their Whiskey-class submarines. The influence of the Type 21 on post-war submarine development cannot be overstated. Virtually every conventional submarine built in the 50 years following World War II incorporated design elements pioneered by the Type 21. The streamlined hull form became universal. Battery capacity was prioritized. Snorkel systems became standard. Torpedo loading automation was pursued. Fire control systems became increasingly sophisticated. The Type 21 established the template for conventional submarines that persists to this day. The crews who sailed the operational Type 21s had varied post-war experiences. Kapitänleutnant Adalbert Snee survived the war and later served in the Bundesmarine, West German Navy, eventually retiring as Konteradmiral, Rear Admiral. He wrote extensively about his experiences with U-2511, consistently emphasizing that while the submarine's capabilities were impressive, the rushed development and limited operational testing created problems that would have required extensive debugging under peacetime conditions. Oberleutnant Hans Werner Kruse, executive officer of U-2511, emigrated to Argentina after the war. His memoirs, published in 1963, described the Type 21 as a glimpse of the future wrapped in the desperate chaos of Germany's collapse. He emphasized the psychological burden of sailing such an advanced vessel while knowing it couldn't affect the war's outcome. We possessed a weapon that could have changed history, but we received it when history had already been decided. The tragedy wasn't the technology, it was the timing. The crew of U-3008, the only other operational Type 21, had different experiences. This submarine surrendered in Norway and was subsequently transferred to the U.S. Navy, where it was commissioned as USS Nemo, later reclassified as T-3008, and used for extensive testing. American submariners who sailed the captured Type 21 confirmed both its capabilities and its problems. The submarine could indeed perform as German specifications claimed, but required considerably more maintenance than conventional U.S. submarines. The testing program revealed specific issues that German crews had experienced but couldn't fully resolve during wartime operations. The battery endurance was excellent, but the batteries required careful management to achieve specified performance. The hydraulic systems worked well when properly maintained, but contamination caused rapid degradation. The diesel engines were powerful but temperamental. The torpedo loading system was fast, but prone to jamming if not operated precisely according to procedures. Lieutenant Commander Roy Benson, commanding officer during U.S. Navy testing, summarized his assessment. The Type 21 represents what German submarine design could achieve under pressure. It's an impressive achievement that would have been far more impressive with another year of development. As delivered, it's a complex, high-performance submarine with reliability problems that combat operations would have exacerbated. Given time to debug the systems, it would have been formidable. The Soviet Union's acquisition of Type 21 technology had lasting strategic implications. Soviet forces captured the Zwickau shipyard in Danzig with 4 incomplete Type 21s and extensive documentation. They also captured the Blohm & Voss facilities in Hamburg with additional incomplete hulls and design documentation. Using this captured material, the Soviet Union developed the Whiskey-class submarine, which became one of their most numerous post-war designs, with approximately 236 vessels built. The Whiskey-class submarines incorporated Type 21 hull form, battery arrangements, and operational concepts while using Soviet machinery and systems. These submarines represented the USSR's primary conventional submarine force through the 1950s and established Soviet submarine design philosophy for decades. The technology transfer from captured German submarines to Soviet production represented one of the most significant intelligence coups of the immediate post-war period. The psychological impact of the Type 21 on German naval personnel extended beyond the immediate crews. Thousands of German submariners in POW camps learned about the Type 21's capabilities from interrogations and propaganda. Their reactions revealed complex emotions: pride in German engineering achievement, frustration at the timing, and relief that they hadn't been assigned to the vessels during their problematic early operational period. Korvettenkapitän Wolfgang Lüth, one of Germany's most successful U-boat commanders with 46 ships sunk, was interviewed about the Type 21 before his death in May 1945. His assessment captured the professional submarine commander's perspective. The Type 21 represents everything we needed 3 years ago. Underwater speed, endurance, firepower, stealth. It has all these, but it also represents everything wrong with German war planning. We developed revolutionary technology under pressure when we needed evolutionary improvements immediately. We built complex weapons requiring extensive testing when we needed proven weapons in quantity. The Type 21 is brilliant, but it's irrelevant because it arrived too late. The interrogation reports from Type 21 crew members revealed consistent patterns. The men were proud of their vessel's capabilities, but frightened by their complexity and operational unpredictability. They had volunteered for submarine service, understanding the risks of combat, but they hadn't anticipated the risks of sailing experimental technology into hostile waters with minimal testing. The fear wasn't cowardice, it was rational concern about systems that could fail catastrophically. The hydraulic torpedo loading system could jam at high pressure, potentially trapping torpedoes partially loaded and rendering the entire system inoperative. The electrical systems could short under battle conditions, causing fires that would be catastrophic in enclosed spaces filled with explosive hydrogen gas. The hull welds, if imperfect, could fail at maximum depth, causing instantaneous implosion. Obermachinist Karl Hoffmann, chief engineer of U-2511, described the constant stress. Every time we dove deep, I worried about weld failures. Every time we ran at high speed, I worried about hull vibrations causing equipment failures. Every time we used the hydraulic systems, I worried about pressure line ruptures. The boat was capable of amazing things, but every capability pushed some component to its limits. We were testing experimental technology while trying to remain combat ready. The combination was psychologically exhausting. The medical records of Type 21 crew members showed higher rates of stress-related illnesses compared to conventional U-boat crews. The chronic pressure changes from snorkel operations caused sinus problems and hearing damage. The vibrations at high speed caused fatigue and sleep disturbances. The knowledge that they were sailing experimental technology created anxiety that manifested in various physical symptoms. The medical staff treating returning Type 21 crews noted that these men showed stress indicators comparable to combat veterans, despite most having never engaged in combat. The comparison between Type 21 capabilities and conventional U-boat performance illustrated what Germany had achieved and what it had missed. A Type 7 U-boat, the workhorse of the German submarine fleet with 703 built, displaced 769 tons surfaced and could make 7.6 knots submerged for 90 minutes before exhausting batteries. It could dive to 230 meters theoretically, though safe operational depth was 150 meters. It carried 14 torpedoes and required 44 crew members. Only 13 more than the Type 7, despite being twice the size and far more complex. Every specification represented substantial improvement. But the Type 7 was reliable, proven, and understood. Crews knew its limitations and capabilities intimately. Training was standardized and effective. Maintenance procedures were established. The submarine worked predictably. These qualities, while less impressive than revolutionary capabilities, were arguably more valuable in 1944-1945, when Germany desperately needed operational submarines rather than impressive prototypes. The counterfactual analysis of Type 21 impact has occupied naval historians for decades. If Germany had deployed 100 operational Type 21s in early 1944, could they have reversed the Battle of the Atlantic outcome? The consensus answer is probably not, but they would have inflicted significantly higher losses. The Allies had developed effective anti-submarine tactics by 1944. Escort carriers provided air cover for convoys. Long-range patrol aircraft equipped with advanced radar and sonobuoys could detect and attack submarines. Hunter-killer groups could pursue detected submarines relentlessly. The convoy system ensured that attacking submarines faced concentrated defensive fire. These tactical innovations would have remained effective against Type XXIs, though less so than against conventional U-boats. The Type XXI's submerged endurance would have allowed it to evade air patrols and remain on station indefinitely. The high submerged speed would have enabled attacks on escorted convoys and escape from pursuing destroyers. The rapid reload torpedo capability would have allowed multiple attacks on single convoys. These capabilities would have forced Allied navies to develop new countermeasures that didn't exist in 1944. However, the Type XXI couldn't have changed certain fundamental realities. By 1944, the Allies were building merchant ships faster than submarines could sink them. American shipyards alone produced 2,700 Liberty ships during the war, an average of 7 per day at peak production. Even if Type XXIs had doubled U-boat effectiveness, the strategic situation wouldn't have changed decisively. Germany would have prolonged the Atlantic battle, but not won it. The resource allocation question remained controversial. The 800 million Reichsmarks invested in the Type XXI program could have produced approximately 300 Type 7 U-boats using conventional methods. If deployed in 1943-1944, these additional submarines might have inflicted more total damage than the handful of Type XXIs that eventually became operational. The revolutionary design consumed resources that evolutionary improvements could have used more effectively in the short term. But this analysis assumes purely military considerations. The Type XXI program also served psychological purposes. It demonstrated that German engineering could still innovate under pressure. It provided hope that technological breakthroughs could reverse military defeats. It showed Nazi leadership taking decisive action in response to the U-boat crisis. These intangible factors influenced resource allocation decisions as much as rational military calculations. The propaganda value was significant. German newsreels showed Type XXI construction, describing the submarines as wonder weapons that would restore German control of the seas. The propaganda didn't mention the quality control problems, the limited numbers, or the operational difficulties. It presented a narrative of German technological superiority that would overcome material disadvantages through innovation. This narrative boosted civilian morale even as it misrepresented military reality. Allied intelligence took the threat seriously. The extensive surveillance of German shipyards revealed the Type XXI construction program, and analysts correctly assessed that the submarines represented a qualitative leap in capability. The Allied response included intensified bombing of shipyards, targeting submarine assembly facilities, and preparing enhanced anti-submarine tactics. Resources were devoted to countering a threat that, unknown to the Allies, would never fully materialize due to German production problems. The bombing campaign against Type XXI production facilities achieved mixed results. Major raids on shipyards in Hamburg, Bremen, and Kiel destroyed some completed or nearly completed submarines and disrupted production schedules. But the dispersed prefabrication system meant that bombing one facility didn't halt the entire program. Components could be manufactured elsewhere and transported to different assembly points. The system's resilience was one of its genuine advantages. However, bombing indirectly crippled the program through effects on German infrastructure. Attacks on transportation networks delayed component deliveries. Raids on electrical generation facilities limited shipyard operations. Bombing of worker housing reduced available labor. The cumulative degradation of German industrial capacity affected submarine production more than direct attacks on shipyards. The Type XXI program required functional industrial infrastructure that Germany increasingly lacked in 1944-1945. The other Type XXIs that reached advanced stages of completion but never became operational told their own stories. U-2502 through U-2552 were launched between May and December 1944. Most underwent extended sea trials that revealed cascading problems. A typical vessel would complete initial trials, return to shipyard for modifications, conduct additional trials, reveal new problems, return for more modifications, and repeat this cycle until the war ended. The submarines existed physically, but couldn't be certified for combat operations. U-3501 through U-3530, launched in early 1945, faced even more severe problems. These submarines were built when German industry was collapsing under sustained Allied bombing. The quality control was minimal. Welds were performed by inexperienced welders because skilled workers had been conscripted. Components were manufactured with substitutes because specified materials were unavailable. Systems were installed improperly because technical documentation was incomplete. These submarines were marginally functional at best. The training program collapsed along with production. By early 1945, Germany lacked the fuel, spare parts, and operational submarines for adequate training. New Type XXI crews received classroom instruction on systems they couldn't actually practice operating. They studied manuals describing equipment they had never seen. They conducted simulated exercises aboard submarines that themselves were still being debugged. The training program couldn't produce crews capable of operating complex vessels under combat conditions. The psychological toll on submarine crews waiting for their vessels to become operational was documented in letters and diaries that survived the war. These men had volunteered for submarine service, completed arduous training, and been assigned to the most advanced submarines ever built. But instead of going to sea, they spent months in training facilities or aboard submarines undergoing endless repairs. The frustration was compounded by knowledge that the war was being lost while they waited. Lieutenant Sir Z. Friedrich Weber, assigned to U-3008 in February 1945, described the experience in letters to his family. "We are submariners without submarines to sail. Our boat exists but doesn't work properly. Each week brings new problems. This system fails, that component breaks. Another design flaw appears. We drill on equipment that will be modified before we sail operationally. We study tactics for warfare that may end before we see combat. The waste is demoralizing." The broader strategic failure represented by the Type 21 program extended beyond the submarines themselves. Germany had invested enormous resources in developing revolutionary technology, while neglecting incremental improvements that could have been implemented immediately. The Type 21 required completely new manufacturing processes, specialized training, and operational doctrines. Type 7 improvements, better batteries, streamlined conning towers, enhanced sonar, could have been retrofitted to existing submarines in months rather than years. This pattern repeated across German weapons development in 1943-1945. The Messerschmitt Me-26-2 jet fighter was revolutionary but arrived too late and in insufficient numbers. The Panther tank was superior to Allied armor, but too complex for rapid production. The V-2 rocket was technologically impressive, but strategically irrelevant. Germany consistently pursued sophisticated solutions when simpler approaches would have been more effective given the time and resources available. The post-war German naval personnel reflected on these failures with bitter clarity. Admiral Eberhard Gott, who had served as Donitz's chief of staff, wrote in 1947, "We lost the war at sea not because we lacked technology, but because we lacked time and resources to properly implement it. The Type 21 demonstrated what we could design. Our failure to deploy it in meaningful numbers demonstrated what we couldn't manufacture. The lesson is that brilliant design means nothing without the industrial capacity to produce it reliably in quantity." The Allied naval response to captured Type 21 technology revealed how seriously the submarines were taken. Britain immediately commissioned studies on implementing Type 21 features in Royal Navy submarines. The United States launched multiple programs to modernize existing submarines with Type 21-inspired improvements. The Soviet Union initiated crash programs to copy German technology. Every major naval power recognized that the Type 21 represented the future of submarine warfare. The British Guppy, later renamed from an American program, and similar modernization efforts focused on improving submerged performance of existing submarines. Streamlining external fittings, increasing battery capacity, and adding snorkels could transform World War II-era submarines into more capable vessels at fraction of the cost of new construction. These programs kept older submarines relevant for another decade, while new designs incorporating more Type 21 features were developed. The United States Navy's Fleet Snorkel program modernized dozens of Gato and Balao-class submarines with streamlined configurations, increased battery capacity, and improved sensors. The modifications cost approximately $1 million per submarine, far less than building new vessels. The modernized submarines remained in service through the 1960s, providing credible conventional submarine capability while nuclear submarines were developed. The modifications were directly inspired by Type 21 features. The Soviet Whiskey-class submarines, built from 1949 to 1957, represented more comprehensive Type 21 influence. These submarines used German hull forms, internal arrangements, and operational concepts almost wholesale. Soviet engineers made relatively few modifications beyond adapting the design to Soviet manufacturing capabilities and component availability. The resulting submarines were reliable, capable, and produced in large numbers, everything that Type 21 should have been. The technical documentation captured with Type 21s provided Allied intelligence with comprehensive insights into German submarine technology. The reports filled warehouses with drawings, specifications, test data, and operational manuals. This documentation revealed not just what Germany had built, but what they had planned for future developments. The information influenced Allied submarine design for decades. The Type 21's influence extended to nuclear submarine development. The USS Nautilus, launched in 1954 as the world's first nuclear submarine, used a hull form influenced by Type 21 research. The teardrop shape, optimized for submerged performance, became standard for nuclear submarines, which operated primarily submerged and needed maximum hydrodynamic efficiency. The Type 21 had pioneered this approach with conventional propulsion. Nuclear power made it fully practical. The crews who had sailed operational Type 21s maintained contact after the war, forming veterans associations and sharing experiences. Their reunions were marked by complex emotions, pride in their technological achievement, relief at surviving, and persistent questions about what might have been if circumstances had been different. The common theme was recognition that they had sailed submarines too advanced for the situation they faced. At a 1975 reunion in Hamburg, Kapitänleutnant Schnee addressed surviving crew members from U-2511. "We sailed the future in 1945. Everything modern submarines do, operate submerged for extended periods, attack without surfacing, evade escorts through speed and stealth, we demonstrated 30 years ago, but we demonstrated it when it no longer mattered." The Type 21's tragedy wasn't technical failure, it was historical timing. We proved the concept too late to affect the war, but early enough to influence everything that followed. The memorial to U-boat crews at Miltenort, Germany, includes specific recognition of Type 21 sailors. The inscription notes that these men sailed vessels representing technological achievement overshadowed by strategic defeat. The memorial doesn't glorify their service, but acknowledges the peculiar burden of operating revolutionary technology in a losing cause. The crews demonstrated capabilities that would have changed naval warfare if deployed earlier, but arrived when the war was already decided. The psychological studies of Type 21 crews conducted by Allied medical officers after surrender revealed patterns consistent with cognitive dissonance. These men took pride in their vessel's capabilities while simultaneously recognizing those capabilities' irrelevance. They had trained extensively to use weapons they would never employ in combat. They had mastered complex systems that would benefit their enemies more than themselves. The resulting stress manifested in various psychological symptoms. The most common symptom was what contemporary psychiatrists called achievement frustration, distress caused by possessing skills and knowledge that circumstances prevented from being used effectively. Type 21 crew members had become expert in operating advanced submarines, but were denied opportunity to demonstrate that expertise. The frustration was compounded by knowledge that their training would ultimately benefit Allied navies who would use captured German technology. The technical intelligence exploitation of captured Type 21s was extraordinarily thorough. Allied naval architects created complete documentation of every system. Components were disassembled, measured, tested, and analyzed. Metallurgical studies examined whole steel composition. Electrical engineers traced every circuit. Hydrodynamic testing evaluated hull performance. The research produced technical reports that guided submarine development for years. One particularly significant finding involved the battery technology. The Type 21's massive lead-acid batteries used advanced plate designs and electrolyte formulations that provided higher energy density than contemporary Allied batteries. The technology wasn't revolutionary, it was careful engineering optimization of known principles, but it demonstrated what could be achieved with systematic development. Allied battery research incorporated German innovations, producing batteries that powered conventional submarines through the 1960s. The hydraulic systems similarly influenced Allied submarine design. The Type 21 used hydraulic power for torpedo loading, diving plane control, periscope operation, and numerous other functions. The integrated hydraulic system was more compact and efficient than electric or manual systems. Allied submarines adopted hydraulic systems extensively based on German experience, though typically with more conservative operating pressures that improved reliability at slight cost in performance. The sonar systems represented perhaps the most militarily significant technology transfer. The Type 21's passive sonar array demonstrated that submarines could detect and track targets at extended ranges using only acoustic sensors. This capability, attacking without visual observation, became fundamental to modern submarine operations. Allied navies developed improved sonar systems building on German foundations, creating sensors that remain essential to submarine warfare. The cultural impact of the Type 21 story extended beyond naval circles. The submarine became symbol of Germany's late-war technological capabilities, impressive achievements that arrived too late to influence outcomes. The narrative of revolutionary weapons that could have changed history if deployed earlier became standard component of World War II historiography. The Type 21, along with jets and rockets, represented roads not taken because Germany lacked time and resources to fully develop them. This narrative had political implications in post-war Germany. Some used it to argue that Germany could have won if only certain decisions had been made differently, if Type 21s had been prioritized earlier, if resources had been allocated more efficiently, if strategic choices had been better. This counterfactual thinking sometimes served to avoid confronting the fundamental immorality of the Nazi regime and the war it initiated. The focus on technological might-have-beens distracted from more important questions about the war's causes and conduct. Historians addressing this tendency emphasized that technological innovation couldn't have overcome Germany's fundamental strategic disadvantages. By 1943, Germany faced overwhelming material superiority from the Allied coalition. Even revolutionary weapons couldn't offset the vast production capacity of the United States, the manpower of the Soviet Union, and the strategic position of the British Empire. The Type 21, like other late-war German weapons, represented tactical sophistication that couldn't compensate for strategic overreach. The submarine's technical legacy proved more durable than its military impact. Design principles pioneered in the Type 21 influenced submarine development worldwide for decades. The streamlined hull form, large battery capacity, snorkel systems, and advanced sensors became standard features. Modern conventional submarines, though vastly more sophisticated, trace their lineage directly to concepts proven in the Type 21. The U-2540, another Type 21 submarine, had a unique post-war history that illustrated the design's enduring relevance. This submarine was scuttled by its crew in Flensburg Harbor in May 1945 to prevent capture. In 1957, it was raised by the West German Navy, refurbished, and commissioned as the research submarine Wilhelm Bauer. The submarine remained in service until 1982, conducting experiments and serving as training vessel. After decommissioning, it was preserved as a museum ship in Bremerhaven, where it remains today, the only surviving Type 21. Visitors to the Wilhelm Bauer can experience what Type 21 crews faced: the cramped interior, the complex systems, the innovative design features, all are preserved. The submarine provides a tangible connection to the technology and the men who sailed it. The exhibits include crew testimonies describing their experiences, consistently emphasizing the advanced capabilities combined with operational uncertainties that characterized Type 21 service. The ultimate assessment of the Type 21 requires acknowledging multiple truths simultaneously. It was a genuine technological achievement that advanced submarine design significantly. It was a strategic failure that consumed resources better spent elsewhere. It was an operational disappointment that never fulfilled its designed purpose. It was a historical artifact that influenced naval warfare for decades. All these assessments are accurate, and none alone captures the complete story. The men who sailed the operational Type 21s, primarily the crews of U-2511 and U-3008, experienced this complexity directly. They served aboard submarines that represented the future but couldn't affect the present. They possessed capabilities their enemies lacked but couldn't employ them effectively. They demonstrated technological superiority while acknowledging strategic defeat. The psychological burden of these contradictions marked them permanently. Kapitänleutnant Schnee, in his final interview before his death in 1982, reflected on commanding U-2511. "We sailed a submarine that could have won the Battle of the Atlantic if it had arrived in 1942. But it arrived in 1945 when the Atlantic battle was long over." That's the essential story, not the technology, but the timing. Germany created something remarkable too late for it to matter militarily, but it mattered historically because it showed what submarines could become. Every submarine built afterward learned from what we demonstrated, so perhaps it mattered more than we understood at the time. The Type 21 program ultimately demonstrated a harsh truth about technological warfare. Innovation's value depends on timing as much as capability. Revolutionary technology introduced when strategically irrelevant remains impressive but militarily meaningless. Germany in 1944 to 1945 possessed engineering talent that created remarkable weapons, but lacked the time, resources, and strategic position to deploy them effectively. The Type 21 epitomized this disconnect, a glimpse of the future trapped in a dying present. The submarine terrified its own crew not because it was inherently dangerous, though it carried risks, but because it represented wasted potential. The men sailing U-2511 understood they possessed capabilities that could have changed the war, if only they had been available earlier. That knowledge, combined with operational uncertainties of experimental technology, created a psychological burden beyond normal combat stress. They feared not the submarine itself, but what it represented, the cruel irony of receiving perfect weapons when the war was already lost. The final statistics captured the program's futility with brutal clarity. Germany laid down 118 Type 21 submarines. It launched 119. It completed 118, but only 2 became fully operational, neither of which fired torpedoes in combat. The submarines that should have terrorized Allied convoys instead became museum pieces and intelligence coups for Germany's enemies. The crews trained to fight the Battle of the Atlantic instead surrendered without engaging. The revolution in submarine warfare that Germany pioneered was perfected by the victors who captured its technology. In the end, the Type 21 didn't fail. It succeeded brilliantly as technology while failing completely as strategy. It advanced submarine design by a decade while arriving too late to effect the war that prompted its creation. It terrified its crews because they understood both its capabilities and its irrelevance. They sailed the future knowing it belonged to their enemies, and that knowledge, that they had helped demonstrate to their adversaries how submarine warfare would evolve, was more frightening than any technical malfunction. The Nazi submarine, so advanced it terrified its own crew, wasn't dangerous because it was unreliable, though it had problems. It was dangerous because it forced its crews to confront the futility of their situation. They possessed the weapon that could have changed everything, delivered precisely when it could change nothing. They demonstrated capabilities that would shape naval warfare for decades, knowing that demonstration benefited their conquerors more than themselves. The true terror of the Type 21 wasn't technical, it was existential. It was the terror of perfect achievement rendered meaningless by impossible timing.